Greetings everyone. I am UDAY Sharma from the EEE Department of Institute of Aeronautical Engineering. Today I'm going to discuss about topic principles of three-phase induction motor. Firstly, let us discuss what is a three-phase motor. Three-phase motors are a type of AC motors that is specific example of a polyphase motor. That means it has more than one phase, two phases connected to it. These motors can be either an induction motor or a synchronous motor. The motor consists of two main components, the stator, the rotor. The stator consists of a series of alloy steel laminations around which are wound with a wire to form an induction coils. One coil for each phase of the electrical power source. The stator coils are energized with a three-phase power source. The rotor also contains induction coils and metal bars connected to form a circuit. The rotor surrounds the motor shaft, and in the motor component, the rotor and produce mechanical output of the energy. The stator is a bunch of wire wounds connected to the stable part. The rotor is a rotating part of a motor. Okay, let us discuss about what is the differences between the single-phase motor and a three-phase motor. As you can see here, we have the single-phase motor. It has an air gap, permanent magnets, rotor. This is the rotor which rotates the stator. The rotating part is called rotor. The stationary part is called stator. But whereas in the AC motors, the rotor, the stator, the windings are given to the stator and rotates. Let us discuss the three-phase motor. This is the stator of a three-phase motor, which is given with three-phase supply. This is the rotating field. Air gap is given and the permanent magnets. As we have discussed earlier, there are three windings for three phases. Stator of a three-phase induction motor. When three-phase supply is given to a stator winding, a rotating magnetic field of constant magnitude is produced. This rotating field induces currents in the rotor by electromagnetic induction. This is the outer frame. The stator slots where the windings are given. Stator windings. Stator core, terminal box where the output terminals of three-phase wires are Y, B comes terminal box of the sturdy base. When the supply is given, rotating magnetic field of a constant magnitude is produced. Principle of a three-phase induction motor. The working principle of a three-phase induction motor is fundamentally based on electromagnetic induction. A RMF or rotating magnetic field is set up in the stator. In the stator, RMF is generated when a supply is given. The stator rotator cut the revolving field, and due to the stationary rotor cut the revolving field, and due to electromagnetic induction, EMF is induced in the rotor. As in the rotor, the RMF supply cuts the and EMF is induced or generated in the rotor. It becomes a current carrying conductor in magnetic field. So it starts rotating as it produces the magnetic field, and we place a current stationary object, or in this case, rotor, EMF is generated in it. This becomes current carrying conductor, or for example, in this case, current carrying conductor, it starts to rotate. This is the principle of a three-phase induction motor. Slip of an induction motor. Induction motor always rotates the speed less than the synchronous speed. The difference between synchronous speed and the rotor speed is called slip. The synchronous speed can be defined as the speed of a rotating the magnetic field, speed at which the magnetic field rotates, where synchronous speed is denoted by the ns, and the synchronous speed is given by 120 f by p, where f is the frequency and p is equal to number of poles. The percentage slip can be calculated by formula ns. The percentage slip is equals to ns minus n by ns, where ns is the synchronous speed as we have discussed, and n is the speed of the rotor. There are two types of motor based on the wiring. In the three-phase induction motor, there are two types: squirrel cage motor and the slip ring motor. Squirrel cage motor contains a windings with a cross line. It kind of looks like a squirrel cage, so it is named like a squirrel cage motor. This is a general use motor which we use in a regular supplies at homes, etc. And this is a slip ring motor which has a slip ring to it, and the windings are shorted. Let us discuss the applications of motor. Slip ring induction motors are always suitable for loads requiring high starting torque and for applications where the starting current is low. Like if you need high starting torque to in any conditions, we can use a slip ring induction motor, three-phase slip ring induction motor. And slip ring induction motor are also used for loads having high inertia, which results in very high rotor energy losses during the acceleration. The slip ring induction motor are also used for loads which require gradual buildup of load. They are used for the loads required speed control, as we can control the speed in an induction motor. We can say that the controlling speed is also a type of controlling speed is also a type of advantage to the induction motor, as we cannot control the speed at a three-phase synchronous motor. The three-phase synchronous motor rotates the constant speed, where we can vary the speed at the induction motor as per our requirements using the speed control methods. Typical applications of wound rotor or slip ring induction motors are crushers, plunger pumps, cranes, hoists, elevators, compressors, and conveyors. Advantages of three-phase motor. The construction of a motor is very simple and robust. The working of an induction motor is very simple. Efficiency of the motor is high compared to the single phase. The maintenance of an induction motor is less compared to the other motors like synchronous motor, etc. The induction motor is self-starting motor, so it does not require any auxiliaries for the starting purposes of a normal operation. Like if you consider the synchronous motor, it requires there is multiple starting methods, like it needs an external motor to start itself. But when we compare to the three-phase induction motor, it does not require any starting methods, so it can start on itself. The cost of the motor is very less compared to the other motors, whereas synchronous motors is high cost. The lifespan of the motors is very high. Disadvantages of three-phase motor. During light load condition, the power factor is very less and it draws more current. So the copper loss is more, which reduces the efficiency during light loads. Like if you have less load, the losses are more, and which gives the less efficiency. The induction torque, the starting torque of this motor is not less. It gives a high starting torque, even as per the requirement of anything. An induction motor is constant speed motor. For the application where variable speed requires, the motor is not used. Speed control of this motor is difficult. Induction motor has a high starting rush current that causes a reduction in voltage at the time of starting. Thank you. This is Uday Sharma signing off.